Okay, everyone can see my screen.
Absolutely.
Yes. Good afternoon, everyone. My name is Chayanisa Sukkasem. Today, I would like to talk on the topic of analysis of optical detection of ultrasound using PDMS thin film. Overview of this talk. At first, I will introduce you about the ultrasound and their applications, and then I would like to talk about the ultrasonic detection method. Objective of this work. Material and methods consist of two parts. The first is the simulation of the behavior of the PDMS thin film under ultrasound wave, and the second is the simulation of the sensing performance of the PDMS thin film changing on the optical sensor platform. Result and discussion about the sensitivity, performance, and summary. Ultrasound is a sound wave with a frequency more than 20 kHz. Ultrasound has been utilized in many applications, such as for analyze the quality of food product in food industry. For example, for medical, ultrasound is used for generate an image of the tissue or organ in our body. And the photoacoustic tomography, ultrasound is used for generate an image of the very small size sample. For example, the blood vessel. This technique requires a high sensitivity performance in ultrasound detection because of the low pressure which is produced on this technique. Nowadays, piezoelectric is widely used for the ultrasonic detection, but this device has limitation in the sensitivity and the bandwidth of detection. Besides this technology, one of the most challenging is to use the light to detect the ultrasound. There are not many optical sensors have been utilized in ultrasonic detection, such as the microlink resonator, surface plasmon resonance, or SPR. And recently, there are the work that presented the PDMS thin film can use for ultrasonic detection with high sensitivity. In this work, we propose to expect the simulation results of the PDMS thin film influenced by ultrasound compression, and to investigate the response of the PDMS thin film using the optical detection platform, and to analyze the sensing of the performance of the ultrasonic detection using PDMS materials. This is the 2D schematic in this simulation. The ultrasound source was set at the top of the system. The ultrasound wave will travel through the medium, the water, and it incident onto the PDMS thin film. The bottom of the diagram is the optical system, which it investigates the change of the PDMS thin film. PDMS thin film, or the polydimethyl siloxane, is the polymer which has the high elasticity and is either viscoelastic. For this work, the simulation of the behavior of the PDMS thin film compressed by ultrasonic wave was calculated by the finite element method on console program. And the simulation of the sensing performance of the PDMS thin film changing on the optical sensor platform was calculated by the Fresnel equation in the MATLAB program. It is the study model on the console program, and it is the parameter were set in this simulation. In this simulation, we study the effect of the acoustic pressure and the thickness of PDMS thin film. And the results show that under the ultrasound wave, the PDMS thin film was compressed uniformly. And the delta D is the thickness change of the PDMS thin film before and after illuminated by the ultrasound wave. And it is the result from the simulation. It shows that the thickness of PDMS thin film with 20 micron can provide the high response of the displacement in under ultrasonic wave. And with the various ultrasonic pressure, it finds out that the relationship between the ultrasound amplitude and the PDMS thin film thickness change is linear, as shown in the figure. And the PDMS thin film with a thickness of 20 micron was chosen and continued study in the optical response simulation. After the finite element simulation, we studied the optical response. The diagram was shown in the presentation. The reflective index of the material as shown in the figure, and the coherent light source with the 685 nanometer was chosen in this study. In this study was calculated based on the Fresnel equation. the Fresnel equation was employed to study the reflection and transmission effect of the electromagnetic wave when the light is incident onto the different medium. And this study, we study the effect of the incident angle and the thickness of PDMS thin film. And when the light is incident onto the interface of two materials, for example, in this case, the light is incident onto the gas and PDMS interface. The important parameter is the critical angle. The critical angle is defined as the angle of the incident that provides the angle of the reflection of 19 degrees, as shown in the figure B. If the critical angle is less than if the incident angle is less than the critical angle, it can provide the transmission and the reflection effect at the interface. And if the incident angle is more than the critical angle, all of light will be reflected at the interface, as shown in the figure C. All of those effects can occur in our optical platform in both of two interfaces. The first interface is interface of gas and PDMS, and the second interface is the interface of PDMS and water. And the result of those effects as shown in the simulation result. The simulation result is in the form of the reflectance. The reflectance is the intensity of the reflected light, and the phase response is the phase of the reflected light. For the case 1, if the incident angle at the two interface was less than the critical angle, the reflectance will be low, as shown in the figure, because of some of light it can go out of the system from a transmission effect. And this effect can cause the reflected light, and what reflected lights can cause the interference, as shown in the result in the phase response. And for second case, the incident light, the incident angle at the interface of PDMS and water is more than the critical angle, all of light will be reflected in this interface. So the reflectance would be equal to 1 because of there are no light energy going out of this system. But this effect can cause the interference between the reflected light from two interfaces. And result as shown in the phase response result. And for the last case, the incident angle at the gas PDMS is more than the critical angle, all of light will be reflected. This case cannot occur any effect as shown in the figure. This is the simulation result with the different PDMS thickness, D, and the incident angle. When we find out that with different PDMS thin film thickness, the reflectance and the phase response is changed due to the optical path length change. And the below figure is show the simulation result with the PDMS with different PDMS thin film thickness. For the left figure is the reflectance result and the incident angle of the 72 and 76. And we find out that the higher incident angles can provide a better response than the lower incident angle. We calculated from the maximum slope of this effect. And for the phase response, with the two incident angles of 0 and 76 degrees, we find out that the low incident angle can provide a better response due to the shortage of the light path length. From the two model simulation, we can conclude it into two figures. For the left figure is the reflectance and the right figure is the phase response. The left show the reflectance of the result of the reflectance of the PDMS thin film under different pressure, ultrasonic pressure. And the right figure that show the phase response of the PDMS thin film under the different ultrasonic pressure. And we find out that the reflectance can provide a sensitivity of the 5.6 multiplied with 10 power minus 7, and the phase response can provide a sensitivity of 1 multiplied with 10 power minus full. This is the table show the comparison of the sensitivity in ultrasonic detection based on optical sensor method, and we find out that the PDMS thin film based phase detection had the highest sensitivity performance. In this work, had investigated through the modeling and computer simulation how to the uniform PDMS thin film employed for optical detection of ultrasonic waves. This shows the summarized advantage and disadvantage of the PDMS thin film based phase detection and the PDMS thin film based reflectance detection. And we find out that the phase detection can provide a high sensitivity, but it requires optical interferometer in the phase detection, whereas the reflectance detection had a lower sensitivity, but it not require the complicated system. It can be designed as a portable system. And the strong point of using PDMS thin film is that it is a low cost and easy to fabricate by the spin coating method. However, the thermal can affect to the expansion of the PDMS. During the experiment, it requires the temperature control unit. In this work, we also thank to the research of Institute of Langsit University and Biophysics and Medical Optics Laboratory, College of Biomedical Engineering, Langsit University. Thank you for your attention. And any questions?
Okay, come to questions. So any questions for our audience? So, or any comments, please? What you're gonna do further for this PDMS thin film? You can explain your research.
Excuse me, can you ask? Excuse me, can you ask the question again?
Yes, what you're gonna do further for the PDMS thin films? What to use for your work?
What do you use to mean the future work or something?
Yeah, explains what the use of your work.
Yes, in this work, we plan to do experiment how to use the PDMS thin film to detect the ultrasound wave. So, and that's why we simulate the result before.
And we have a question in the chat room. What is the indications to users for the sensitive of as detection type? So you can answer that in microseconds, is it? Implications?
Indicated. Yes, for the yes, actually this technique is not widely used for the medical for the ultrasound in the clinic because of this is a high sensitivity device. Actually, this technique is used in the photoacoustic tomography system. Actually, this technique is designed for photoacoustic tomography technique more than the it's used better than the ultrasound imaging in the clinic, I think.
Is it harmful?
No, the PDMS thin film is a it have a
compatibility.
PDMS thin film. It has the compatibility to our body and the light. It's not harmful to our body.
Okay, that's all. So thank you for Ms. Chayanisa Sukkasem for the presentations. Okay, very nice work.